Hi, my name is Mr. Evangelista, and in this video we're going to be talking about circuit calculations. Today we're going to be doing a series circuit. So here we have our series circuit. We've got three resistors, 3, 10, and 5 ohms, and we have a battery with 9 volts. We're going to have to figure out the total voltage, the total current, and the equivalent resistance for this whole circuit. And we're also going to need to figure out the voltage drop across each resistor and the current flowing through each resistor. Notice the verbiage there. Voltage is drop across each resistor, and current is flowing through each resistor. Okay, we're going to need several things to figure this out. The first thing is Ohm's law. Ohm's law says voltage equals current times resistance. That means if we have two of those things, we can figure out the third. The next thing we need to know is that in a series circuit, current is the same throughout. This is because there's only one path for the electrons to go through. So the amount of electrons flowing per second through resistor 1 has to equal the amount of electrons flowing through resistor 2 as well as resistor 3. The total resistance in a series circuit is equal to just the sum of each resistor. Okay? And the voltage drop of the whole battery equals the voltage drop in 1 plus the voltage drop in 2 plus the voltage drop in 3. Let's take a look at all of these combined. Let's plug in the stuff we know. The total voltage, we know we're using a 9-volt battery. Okay, and we know the resistances for each of our resistors, 3, 10, and 5. Let's try to figure out the total equivalent resistance. We can get that by summing each resistor. So we just sum each resistor. That's 3 plus 10 plus 5. We get 18 ohms. That means that if I were to take all of these resistors out and replace them with one resistor that was 18 ohms, it would work the exact same way. It's the equivalent resistance. It would work the exact same way as if I were to take all of these out and just put in an 18 ohm resistor. We have the voltage, we have the resistance, we have two of the three, so we can use Ohm's law to figure out the current. Here's Ohm's law rearranged. It's V over R equals I. That's 9 over 18 equals half an amp, 0.5 amp. Okay. Now we just said that the current throughout the series circuit is the same throughout. So if that's 0.5 amps, all of these are 0.5 amps. And look at here, we have two of the three, so we can use Ohm's law to figure out this missing third. Ohm's law says V equals IR, so 0.5 times 3. We get 1.5, 5, and 2.5 for these. Now, notice that these voltages, 1.5 plus 5 plus 2.5, equal the total voltage of the battery. So what that means is the voltage right now coming out of this battery is 9 volts. When it passes resistor 1, the voltage drops by 1.5. So it will now be 7.5 coming here. And then after resistor 2, it drops 5 volts. So 7.5 now becomes 2.5. And then coming over here, it drops another 2.5 volts. So now we have equaled the total voltage drop of the whole circuit. 9 volts was the total voltage, and each of these adds up to the total voltage. Now let's take a look at what this looks like in a circuit. So here we have this circuit built. We have our 9-volt battery, our 3 ohm resistor, 10 ohm resistor, and a 5 ohm resistor. So let's check our voltage drop across each of these. So our total voltage drop, right, should have been 9 volts. Okay, the voltage drop across here was 1.5, just like what we said. The voltage drop here was 5, just like we said, and the voltage drop here should have been 2.5, just like we said, yes. And then now let's check the current. The current across each resistor should be the same throughout. So here it's 0.5 amps, 0.5 amps, and 0.5 amps.